We will begin with BIM 101 to give you the basic understanding of what BIM is and why it's important. So what is BIM? BIM stands for Building Information Modeling. Let's start to define BIM by understanding what BIM is not. There's been a lot of misconceptions about what BIM is. First, BIM does not equal 3D. Many people think that if a project is done in 3D, that it is BIM. Modeling is just part of BIM, but does not equal BIM. Second, BIM does not equal data. Yes, it's true, the I in BIM stands for information, and there's a lot of information or data included in a BIM model, but BIM does not equal data. Next, if BIM does not equal 3D and it does not equal data, it must be the combination of 3D and data, right? No, BIM does not equal the combination of 3D and data. Finally, BIM does not equal Revit. I hear a lot of companies all the time refer to Revit as BIM. Revit is just a modeling tool that is used on a BIM project. A project can be done in Revit and not be a BIM project. Or a BIM project can be modeled using other software as well. One term that BIM does equal is VDC, or Virtual Design Construction. The term BIM and VDC are essentially interchangeable. Many on the design side of projects prefer the term BIM, while many on the construction side of projects prefer the term VDC. So now that we understand what BIM is not, here is a textbook definition for BIM. This is one of the first definitions that I ever saw about BIM. I originally saw this definition over 15 years ago. I know that there are many definitions out there, but this definition makes sense to me, so let's just read it. Building Information Modeling, or BIM, is the creation and use of coordinated, internally consistent, computable information about a project in design and construction. There are a lot of C words in this definition: coordinated, internally consistent, and computable information. Coordinated is referring to the trades that are typically coordinating with each other on BIM projects. They are looking for interferences and trying to make sure what they are installing is not interfering with other trades. So typically, on a BIM project is more coordinated than on non-BIM projects. Internally consistent refers to typically on a BIM project, the information for the project is coming from a single source, the model. The model contains all the data and information. For example, if a door schedule needs to be updated, you do not update the schedule. You update the model, which then automatically updates the schedule. So the model and the schedule are always in sync with each other. This makes a BIM project more internally consistent. Computable information refers to the fact that the model is not just dumb lines, arcs, and circles. It's intelligent modeling components that can be used for many analysis needs. The last part of this definition describes who is taking part in the BIM process. It's not just the designers. It's the entire project team, the designers and the contractors. If I could change one part of this definition, I would add the word owners to it, because owners are beginning to drive the BIM on projects by making BIM requirements. The owners are the ones using the data in the BIM model for facility management when the construction is completed. So owners are very involved in the BIM process. If we take a look at traditional CAD for a second, we will see that traditional CAD is first of all focused on production drawings. Typically, when a project starts using traditional CAD, the team starts by saying, okay, we need a floor plan, an elevation, some sections, and so forth. They're more focused on the drawings as opposed to the design. Traditional CAD also typically has the project information stored in multiple files and formats. as opposed to all the information being stored in a single model. Traditional CAD also is difficult to manage changes late in the design. And finally, there's a risk of data loss during multiple discipline coordination. The traditional CAD documentation process consists of multiple drawings and drawing types. We have floor plans, elevations, sections, schedules, details, and maybe even a 3D model. All of these drawings are created in separate drawing files, and then they are placed onto sheets. This makes up the final documentation. When we compare that process to a BIM process, it's completely backwards. Instead of having separate drawing files, we have a single model. We develop the model, and out of the model we get our plans, elevations, sections, details, schedules, and the drawing set. This allows us the change it once, change it everywhere mentality. When we make changes to the model, it automatically updates the floor plans, sections, details, schedules, and our drawing set. With BIM, we do not have the problem of an element showing up in a schedule that has been deleted from the model. Once it's been deleted, it's deleted in all views of the project. The difference between a CAD process and a BIM process leads to a change in the way we approach projects. As I previously stated, the CAD process starts by thinking about the documentation, whereas the BIM process allows us to focus on the design, and the documentation is a byproduct. BIM requires a new way of thinking. To give us a better understanding of the importance of BIM, I want to introduce the McLean Curve. This graph has been around for a long time, but it's a good tool to use to understand why BIM is needed. The bottom or horizontal part of this chart represents time. We have the different phases of a project: pre-design, schematic design, design development, construction documents, procurement, construction administration, and operation. The vertical leg of this chart represents the amount of effort or the amount of the effect we can have on a project. The first curve is indicating the ability to impact cost and functional capabilities. Early on in a project, changes can be made that will drastically have an effect on the cost or function of the project. For example, we can change the design from a multi-story building to a single-story building. As the project continues, we are not as likely to make drastic changes because we are too far along in the project. The second curve represents the cost of these design changes. As the project progresses, changes that are made will become more expensive. The third curve represents the traditional design process. Majority of the work is done on the project during the construction documentation phase. This is where designers are in crunch time. They will pull in extra people to get the project finished and out the door. But if we look at this is past the point in the project where we can make changes, or the cost of these changes will not be affordable. Which brings us to the last curve. This represents the preferred design process. It is pushing the bulk of the work back to an earlier stage of the project, which will allow for changes to be made that will affect both cost and function while the cost is not too much. This represents the BIM process. BIM allows the design to be focused at the beginning of the project, and it allows the majority of the work to be done prior to crunch time in the project. BIM is more than just a model. There are many ways that the model can be used to benefit the project. Here are just a few. Conflict resolution allows contractors to find clashes with trades prior to construction. Quantity takeoffs. The model provides exact quantities of all elements in the model. If items are added or removed, quantities are instantly updated. Simulation and analysis. There are many ways the model can be used in analysis tools, such as lighting analysis, airflow analysis, or even acoustical analysis. Context line of sight studies. Just being able to see or visualize the building. You know, civil and site designers are able to model entire cities, so being able to see the project in a larger context is critical. Facility management. Owners are taking the data from the model and plugging it into facility management software to operate the facility after construction is completed. And of course, construction documents and specifications. We are able to compile different views of the model onto sheets to make up our documentation. In addition to what we can get out of the model, the data we can input into the model is endless. Depending on what the model is going to be used for, we can populate the model with additional information. Here are some of the types of data that could be inputted depending on how it will be used downstream. BIM is so much more than just floor plans. This is where the I in BIM really comes to life, and the information is the key to the process.